If the atmosphere was not there, if it was not above us and around us, we would have to be walking around in spaceman gear or spacewoman gear. And so fortunately, because of the atmosphere, what it does for us, we don't have to do that. Now we would call our good friend the electromagnetic spectrum in its individual parts. Of course, on the left-hand side, we're going to have our more harmful to us as human beings, and so we think about X-rays. The idea is it's so energetic that it can actually those rays can pass through our skin or our soft muscular tissue to see the inside and see the bone, which it obviously can't go through. UV rays, we know that these are harmful for skin cancers and possible genetic mutations. And so those on the left-hand side are obviously more harmful. And so we're going to look at the atmosphere as a filter. And down here in the troposphere, plants and animals are fortunately protected by Earth's atmosphere. So if you think about the shortwave energy, that's key is the ionosphere, which we're getting ready to talk about. The ionosphere does a good job of filtering out as the absorption of those gas particles in the upper level are absorbed and filtered out. Then we go down to the ozonosphere, and that's where we get the ultraviolet rays. They're not filtered out in the ionosphere. Instead, they're filtered out down in the ozonosphere. And so key is the ozonosphere does a good job of filtering out the UV rays to prevent them, which are still rather shortwave in nature, from harming human beings actually on the surface. And so one of the things that you're starting to notice, as we'll talk about in the following examples, is the fact that the ozone, it is decreasing. And so the key there, that as it decreases, it allows more UV rays to reach the surface. And we all know this. If we go to the beach, the reason why we're putting on sunblock is to prevent the UV rays from coming into contact with our skin.